Hello, everybody. Thank you for coming here. Our next speaker is Chris Theroff. He's a student at the Wentworth Institute of Technology. He spends a lot of time writing code, playing with 3D printers, and using free software and hardware in his research. And so please give him a warm welcome.
Cool. Thank you, everyone. My name is Chris Theroff. I'm a computer science student. I play a lot with robots and with 3D printing and stuff. So I wanted to talk about how the 3D printing community has benefited from free software and what the free software community can potentially do to benefit from 3D printing. Starting off here, I'm just going to spend one slide making sure we're all on the same page with what 3D printing is. It's an additive manufacturing process where we're building a part by extruding a hot plastic layer by layer by layer when we're talking about FFF or FDM, fused filament fabrication. You might be more familiar with the term FDM, but that's a trademark term, so I'm not going to keep using it. But again, it's the same concept. We're extruding a hot plastic when we're doing the majority of consumer-grade 3D printing. Some quick history here. Stratasys patented and trademarked the term FDM, which is the type I was talking about. They did that way back in the late 1980s, and that patent expired in around 2009. So they've been credited with just an explosive growth in this field. As a result, partly of the patent expiring, we've seen printers becoming 2 orders of magnitude cheaper, and we've seen a hobbyist movement begin to develop. One of the major players in that hobbyist movement is RepRap. They're still around. They are a project out of the University of Bath, which has been creating hardware and firmware for 3D printers. The goal is to create a printer that can create itself. And so they released all of their hardware and all of their firmware under the GPL, and they've been credited with a significant growth of hobbyist 3D printing. Of course, when free firmware became available, the DIY crowd got interested and a maker movement took over. We saw forum communities growing, we saw wikis popping up. Part of this was RepRap, a lot of it was outside of RepRap. But it all came back to this emphasis on tinkering and sharing designs and sharing ideas. Again, it wasn't really feasible for the average user at first, but that began to change once Libre hardware came around. We start looking at Libre hardware, we're talking about electrical and mechanical hardware being made free and being made accessible to the end user, which really appealed to the DIY crowd. So KiCad files, which would be electrical schematics, you can see an example of a PCB layout in the top right. That is the Duet 2 Wi-Fi, which is a board that can be used to control a 3D printer, control the motors on a printer. That's totally free and open source, and it's being opened in KiCad, which is free and open source. And it was designed in KiCad. And mechanical schematics are also being made available. You can see in the lower right, that is the part design for the E3D V6, which is a hot end. It's the bit that actually extrudes the plastic. That document is released under the GDL. So we're seeing a lower barrier to entry to kits and a lower barrier of entry just for people who are interested in building stuff from scratch. So there was a quality improvement in the printers that were being manufactured, and then by extension of that, the parts being produced were higher quality. As a result of this increase in quality, we started to see this concept of a prosumer market, where DIY moved from these totally from scratch or from kits to more high quality kits, and from even the kits to complete systems. Where high quality, both of the printers themselves and the parts that they were producing, was a really high priority, as was ease of use. So the names that you'll keep seeing pop up here would be Aleph Objects, which produces the Lulzbot Taz stuff that was Respect Your Freedom certified, Prusa Research, and several others. So as a result of where this all comes from, we're seeing that free software makes up a very significant portion of the desktop market. I'm trying to prove that here. Finding free software in 3D printing. The data that you're looking at was taken from the Quarter for Analysis of 3D Hubs. They have a community of people that do 3D printing, and they looked at the top 10 as ranked by the community. I've highlighted in green the ones that are exclusively free and open source software in their firmware, which is really cool. We're seeing 8 out of 10, and that's a trend that really continues as you go down the list. There's an enormous amount of free and open source software, and kind of proving that again, if we look at similar data, this time ranked by the number of parts printed, we're again seeing that the majority of popular devices in this field are free and open source firmware. So based off of this data, we can start to extrapolate some community values. The 3D printing community really values the ability to tinker, the ability to share and to modify their own designs and other people's designs. Part of that is that free hardware the actual mechanical schematics and the electrical schematics becomes a priority as it relates back to the tinkering. As kind of a case study, I guess, we can look at MakerBot. Many of you are familiar with MakerBot as being non-free and not something that you should really look at for 3D printing. And that's true at the moment, but previously they were actually a very significant driving force for free and open source software and hardware in the 3D printing space. I'll talk more about them later, but at one point in time they had a 40% market share when they were doing exclusively free and open source. Through a number of factors, they went non-free and there was a loss of faith in the product, and they're now a declining market share. They're less than 5% of the market. So kind of showing that this community does care about the ability to tinker and to modify. Connected to that would be free hardware. A significant number of free software printers are also using open designs. Again, we're seeing Aleph Objects producing the Lulzbot, that's open, Prusa, Ultimaker. Those are all names that if you had a chance to read the manufacturers of those top 10s that I showed you, they kept coming up. And that's, again, a trend that continues throughout really the entire desktop consumer 3D printing industry. We're seeing electrical boards being open, we're seeing mechanical designs being open. All of that is tied back to this increased ability to repair, ability to modify, the ability to tinker is what the 3D printing community is really valuing here. So let's draw some parallels between our communities here. Again, I keep saying this, but it's all about the ability to share and to modify, both between our community and their community. Both of our communities value openness in design. Both of ours find hack value kind of interesting. That's not really as critical, but I'd be willing to bet everyone in this room thinks it's kind of funny that that desktop lamp was completely 3D printed and it's also a 3D printer. It's like kind of it's not really important, but it's kind of fun. There is a conflict between our communities, and that main conflict is this concept of freedom. Is it good or is it a moral obligation? The 3D printing community is all about the ability to tinker. So as long as something being non-free doesn't get in the way of tinkering, it's not a real obligation for that community in general. Whereas, of course, free software movement, we would look at that as more as an ethical obligation to be free and open. Despite that conflict, I do believe that our communities are highly compatible and that there's a lot of opportunity for spreading free software through 3D printing. Of course, 3D printing also ties back to free culture. We were promised this digital revolution in the same way that we saw with digital media, where we saw files could be copied, and so people could share software, people could share art, people could share media, and it was this digital revolution. And we were promised the same thing with 3D printing, as though 3D printing would be as universal as your toaster or your oven or your microwave or whatever. And that didn't quite play out like that. But the promise is still there, because although physical objects can't be shared, the ideas behind the physical objects can be. So you can't have two identical objects, but you can have two objects that are separate and have been created independently, and we each have our own, we can each modify our own. So again, we were promised this revolution that doesn't seem to have happened, but it actually is. It's already taking place in engineering and in research, and we see it all the time there. It just hasn't quite made it over to the consumers yet. So Libre hardware as it's important to freedom. In general, the community of free and open source people haven't been as strict on hardware as we've been on software. Generally, hardware hasn't been rejected for being non-free because it's viewed as a lot less attainable. But accessible manufacturing allows for much more open design. We're seeing manufacturing capability becoming really public and getting into the hands of the end user, which is something that hasn't really happened since the Industrial Revolution. So as a result of all of that, the Free Software Foundation stance is, I'm quoting here from Free Hardware Designs, distributing a non-free functional object design is as wrong as distributing a non-free program. For the same reason as it's something you use, you should have the right to be able to modify it to your needs, share it, and so on. So what's the impact of 3D printing growth on freedom? As I've already shown, free software has a pretty significant market share for desktop printers. And what that means is that 3D printing growth is free software growth. The issue is that a lot of users remain unaware of software freedom. It's not the priority for them so much. So it's not as present in their minds. But the common ground in the values means that we can fix this. more reasons to pay attention to 3D printing. 3D printers are becoming a lot more accessible. They're becoming more accessible partly in the fact that they're more user-friendly. There's a lot more automation that just handles the behind-the-scenes working for you. For example, I have a printer that it will automatically detect if movement on any of the motors is being restricted, and it'll just correct it if it can do that. So you don't really have to think about the printers as much as you had to 5 years ago. You can kind of trust them to work. The supporting software, the software that we use to control these devices from our PCs, is really, really easy and is largely free and open source. It's very common to find these printers in less than $500, so it's even easier to get your hands on them. They're a very common tool in makerspaces, in libraries, universities, schools, those sorts of places. It's very common to find these things there, so it's easy to get your hands on 3D printed parts that way. And even if you don't have any experience with actually designing parts, there are very large communities of people sharing their parts freely online. So again, a lowered barrier of entry that way. As an example of customizable parts, one of the most well-known online repositories of 3D printed parts is this place called Thingiverse. And so this guy on Thingiverse has shared his parametric multi-blade propeller generator, which I downloaded and I opened in a tool called OpenSCAD. OpenSCAD allows you to basically do scripting to describe a physical object. And I did some modification and I was able to print out a little propeller that might happen to meet my very particular niche needs. So parts can be shared and customized for different needs, and it's even easier than it's ever been. Talking about the spread of 3D printing resources, just to kind of demonstrate how much this has grown, I spent the day just looking for 3D printers, and I found them pretty much everywhere I thought to work, or to look, rather. Of course, I'm a student at Wentworth, so I was able to find a couple spaces there. I spent the day roaming around here, and I found some spaces here at MIT. I'm working at Tufts. They have a space. The Boston Public Library has one, Brooklyn Library. These places all have printers and setups where members of their community can go in, get something printed. It's either free or very, very cheap. In general, we're seeing that libraries are using the desktop printers, which again is dominated by free and open source software, and universities are using both a combination of desktop and industrial printers depending on their particular needs. So we've talked about desktop. Let's take a look at industrial freedom. It's non-existent, more or less. And the reason that's kind of critical is because universities are using a lot of industrial printers. So there has been a decline in freedom. Why has there been a decline in freedom? Largely because the industrial printers, being non-free, meet the needs of universities and these big technical institutions better. Universities are willing to pay for industrial machines, but hobbyists aren't. That's a pretty big factor. The fact that it costs $10,000 is something that I'm not willing to really shell out, but a large shared space would be. Also the needs, the ease of use. The desktop free and open source stuff has become very, very easy to use, but it's not a closed system, which to us is great, but to a university that wants to just hand 3D printed parts to the machine and not ever deal with it and think about it, and if it breaks, they can call the manufacturer and they'll just take care of it. That's more what they're interested in. Also advertising. Free and open source machines are using more word of mouth. If you ask people in the 3D printing community for advice on a 3D printer, they're going to recommend something like a Prusa or a Taz, which is free and open source, over a MakerBot or over something like Stratasys. But that's not something that universities or libraries really have access to. And also, Stratasys will send people to universities to advertise their machines. Markforged does it too. They'll show off their prints and pitch it to you, which is not something really that the free and open source communities can afford. And then also hobbyist experience, tying back to people in the know what stuff is worth the money. So is the free software movement losing traction in the field? Well, all of the spaces that I toured, all the spaces that I found, are less than 4 years old. And the reason I mention that 4 years is because the most recent Free Software Foundation essay on the topic, even mentioning 3D printing, was 2015. So there has not been a significant amount of attention, perhaps, that 3D printing deserves, in my opinion. There was only one manufacturer that was Free Software Foundation certified. Several printers were certified as a result of that, but it's one manufacturer, and as we've seen, there are many manufacturers that could meet that criteria. There's also SLA 3D printing that's becoming more accessible. SLA printing is a different style of 3D printing, and it's becoming a lot more appealing to hobbyists because it produces significantly higher quality parts. I have some here if people would like to check them out. And it's becoming a lot more accessible. I was only able to find even one open source SLA printer, which isn't great. And then also, I don't believe that the demand for design tools are being adequately met in this field. So one of the major issues with Freedom in the consumer market is that MakerBot has a pretty significant presence in makerspaces and in libraries. They're very popular as a first library or makerspace purchase. They get donated to libraries, to schools, things like that. They try to be the Apple computing of 3D printing, this concept of it's a closed system, you don't need to think about what's under there, it just works. And so that really appeals to libraries, and it really appeals to makerspaces. They're the consumer arm of Stratasys, which I mentioned because Stratasys is publicly traded, so we can see that this model hasn't been working as well as it had been, but they are still a significant presence in libraries, a significant presence in makerspaces. I keep talking about MakerBot, so I'm going to bring up their history briefly just to brief you all on it. They were originally a really major player in free software and in open design. They really pushed for that stuff. As I said earlier, they had a 40% market share in 2011 when they were doing that sort of thing. But then a venture capital firm joined the board, and they were less interested in openness. Zachary Smith, one of the founding members, was very pro-open design and got kind of pushed out as a result of being open. They were acquired by Stratasys, which is the guys that patented and trademarked all the FDM stuff. Around that same time, they went closed source. The community felt really betrayed by this closing down, so they suffered as a result of that. There was also an enormous loss of trust in the product. There was actually a class action lawsuit against MakerBot because one of their newest printers was just bad in terms of the quality and the reliability. They're in decline, they're still in decline, but they're still popular in libraries, again, because of that friendly package. And a lot of the time, libraries don't actually know how bad they have it because they don't have any of the really high quality, cheaper printers to compare it to. Even though they're not really thinking about the free and open part, which is again a benefit. So I think we should look at libraries as potential injection vectors for freedom. Local libraries are how people will encounter 3D printing for the first time. And that means it's an opportunity to introduce people to free software. Libraries are already very receptive to the concepts of openness, so it's not really a conflict. I would encourage you all to become familiar with the names Aleph Objects and Prusa Research. Aleph Objects produces the Lulzbot printers that have been Respect Your Freedom certified. Prusa Research unfortunately hasn't been Respect Your Freedom certified, but I'm very confident that if they went through that process, it would be. People in the hobbyist community know that both the TAS 6 and the i3 Mark III's are significantly higher quality machines than the MakerBot Replicator Plus that a lot of libraries will go for. Everyone in the community will tell you that they are free and open software, free and open hardware, easy to maintain, significantly more automated, significantly more reliable. And again, I'm happy. I have prints here you can ask me about, and I can show you that it is noticeable. And they're also cheaper. You can get 3 of the Prusa i3 Mark III's for the cost of 1 replicator, which is pretty cool. So, libraries are a potential opportunity for freedom here. So why prioritize 3D printing? First of all, it's an accessible market, or accessible manufacturing rather, which we've seen in our keynote as an example is something really powerful, really positive. Bringing manufacturing to people that wouldn't otherwise have it is great. It's a growing market. It's projected to double in size every 3 years. And as I've mentioned, 3D printing growth is free software growth. So if we can stay in here, then we are going to get brought back up as, free software will get expanded as 3D printing expands. And in addition to that, there's opportunities that are being offered for free software in 3D printing that we don't really see elsewhere. In general, I think 3D printing can be viewed as a potential driver for freedom. I've already talked about accessible manufacturing. It's also a potential driver of mechanical freedom. Again, thinking back to this morning's keynote, but also in the sense that people wanting to create things will cause them to use the tools that will allow them to create things. So we will see more people using those tools. We'll see more people contributing to those tools, finding bugs, that kind of thing. We've already seen that happen in the electrical space, where people are designing electrical boards for 3D printing in KiCad, and KiCad, as a result of having a larger user base, is better off for it. So there's a potential driver for electrical freedom in that sense. And similarly, we can see the same thing occurring in open source software in the free and open source areas there. So the short version is 3D printing is a free software opportunity. There's a significant amount of free software just occurring in this community, despite the fact that that was not their initial intentional goal. Hobbyist and library needs are easily met by free software. The community already knows this. And 3D printing community values are very similar to the existing values of the free software community. And in addition to that, 3D printing directly promotes the values and the needs of free culture. I think the main reason 3D printing is able to help us is the fact that software is invisible. It's not real. We're all software people, more or less, so we understand it. Most people don't, and that's something 3D printing can potentially help us with, because 3D printing is tangible, it's tactile, you can, hold things. You can't really do that with software. And so I can hand you, this object and say, you can make one of these, I can teach you how to modify this, and now you can have one. And that's something really tangible and something people can interact with. People are taking freedom for granted, I think. People, my generation in particular, didn't really go through the same transformative thing that perhaps my parents went through. They didn't grow up with this technology. They didn't see the impact it had. So, I think people will take software freedom for granted unless we can make something tangible that they can interact with it to really help them understand it. And it goes back to this concept of technical literacy. If you don't understand what firmware is, it's very difficult to convince you that making firmware free is important. So potentially 3D printing can help us here. I'm optimistic about opinion being ready to shift. We can look at Facebook as an example of this. Facebook was given an enormous access to data by their user base, and as we all know, they abused that access. People were kind of shocked. There was no oversight, and people abused this lack of oversight. And as a result of that, an awareness of the danger spread. And I think people, I'm speaking about my generation in particular because that's the people I speak to mostly, people were ready to shift. And we did see a shift. I don't use social media, but a lot of my friends moved over to Instagram. So Mark Zuckerberg doesn't care because at the end of the day, whatever. So it's not really a benefit in terms of freedom, the fact that this shift happened. We went from 0 to 0 in that area. But I think it does show that there's an interest in ethical technologies. People are willing to think about this. People are willing to change. We just need to capture their interest. And that's something 3D printing can help us with. In 3D printing, really engaging and easy projects are possible. They're really easy to integrate into schools, which is something that's a potentially enormous benefit. We're already seeing them being integrated into middle school and high school programs, and that's something I can personally attest to. My own values about openness and sharing of designs was largely shaped by the fact that my high school had a 3D printer that I could play with. University programs, I'm seeing at my university, math professors even, outside of the mechanical fields where this stuff gets used all the time, math professors will go into a printing lab and 3D print a three-dimensional function. And now it's something where you can actually see potentially how things relate. It's very viable to insert 3D printing into pretty much every curricular field. So it appeals to educators, it appeals to students, and also 3D printers are kind of mesmerizing. They get your attention. They make you start thinking about things when you see them that you might not have otherwise thought about. Going back to that printer I had access to in high school, my high school had a lot of issues with poverty, people who really weren't thinking about education as a priority. And it was kind of amazing to see people who had never considered college or anything like that, seeing this 3D printer and saying, this is really cool. Engineering is a really interesting concept. And how amazing would it be if we can be the ones to provide them the tools to take advantage of that new interest? As free software, we are uniquely situated in the fact that we are best qualified to release and to share these tools. That's what our movement is about. So there's opportunity there that is currently being taken by proprietary tools that are being released for free but are not free software. As an example, here is the Open Hand project. I kind of wish I knew more about our opening keynote when I started talking about 3D printing in the medical field, doing good there. But just to kind of show that that is not a unique story, the Open Hand project is designing, that's the ADA by Open Bionics. They do open designs for prosthetics. And they've been medically certified in the UK, and they're going to actual people who are using them in their everyday lives. And it really demonstrates the benefits of free technology, because you can download all of the files for that and modify that and print your own and give them to a friend if that's what you'd like to do. And it really shows the benefits of having access and open access to these manufacturing tools and these design tools and free software. It's impossible to take that for granted. And that's something that is tactile, is real, that we can share and spread free software through. And you know, it's great press. It's a great story hearing about how someone's life was, as we saw with the opening keynote, enormously positively changed thanks to the free software and the free hardware. Up until this point, I've been talking pretty exclusively about the actual firmware on these 3D printers and the 3D printers themselves, but there's more to it than that. There's also the rest of the tool chain, where, you know, all happening on your PC. All of that stuff is available on pretty much every operating system, so if you're worried about freedom at that level, that's checked off, that's okay. Slicing, which is the process by which we go from a mechanical object file to instructions for the printer, that's largely free. In general, if you are using a free and open source printer, they're all using this open standard called G-code, and so there's options for you to control your printer through free and open source stuff that way. Part design is where we slip back a little bit. Part design is largely proprietary. Whenever we start talking about, or I'll get to that later, CAD. CAD is important. The fact that we're kind of slipping behind in CAD is a little scary, because everything in the modern world is designed in CAD. We're talking about the entire man-made universe here, and that's controlled by proprietary software. That's designed in proprietary software. So having non-free hardware, as we know, that blocks an additional level of freedom, but having non-free design software blocks even that, because we can share all the design files for everything we want, but if it can only be opened in design or in proprietary software, that's not real freedom. So having accessible design is essential to freedom. Are there electrical options? Yeah, I've spoken about KiCad already. The story behind that is that was created by, I forget the man's name, unfortunately. Well, no, it was actually created, right, it was created by an independent Frenchman who was taken over by CERN, and they wanted to really push it into becoming a high-quality, professional-level electronic design tool, and they succeeded. Mechanically, we have less options. Whenever we talk about free and open source CAD, Blender comes up. So I'll talk about the history of Blender briefly. It was developed as an in-house animation tool. It was later released under the GPL version 2 after a very long story that I won't get into. And it is a professional CAD tool. It's been used in professional environments on films many of you have heard of. It did the pre-visual effects in Captain America: Winter Soldier. The credit sequences in Wonder Woman, some of that was done in Blender. A lot of the promotional artwork for Super Smash Bros. On the Wii U was done in Blender. So this is a professional quality CAD tool. And it does shapes, it does meshes. You can create whatever you need to. That's a model of an engine that has been 3D rendered in Blender. It's capable of physics simulation. So it sounds like a really great candidate for mechanical design. The issue is that it's not really a parametric design tool. And when I'm talking about parametric design in relation to mechanical engineering, I'm talking about performing design by parameters. So it's about creating shapes that are of specific lengths, specific widths, revolutions of very real dimensions. You can see a part that I threw together here that is of 50 millimeters long, 10 millimeters deep, 8 millimeters high, very tangible. And that's critical for real world parts where you need things to be specific dimensions. That's a largely proprietary industry. But free software does exist. When we talk about parametric free design software, your best bet is going to be FreeCAD. FreeCAD is a parametric design tool. They're an awesome project. They do really good work. And I've spoken about how big a need CAD is, so they're a really, really important project, I think, based off of that. But I wanted to find out, is FreeCAD a suitable replacement for SolidWorks, Inventor, the industry standard tools in this field? So to find out, I took my friends' logs, and they were surprisingly okay with that. I have a lot of friends that are mechanical engineers, and they all use SolidWorks in their day-to-day lives as professionals. So I was able to get logs from about 600 sessions, and I parsed that for operations information. So every time they clicked on anything on the toolbar, I had a record of that, which I then parsed for unique operations. So now I had a count of every time something was happened. And I got a data set of the usage frequency, which I'm going to show a smaller version of, because just for the sake of brevity. But if you want the full data set, get in touch and I'll give it to you. So the top 20 operations out of the 175, this is what they look like. That's not really helpful, but it's just to put things into perspective. These are all pretty standard tools that exist within the industry. So how does FreeCAD measure up? Pretty well, actually. If you look at, can FreeCAD do it? Yes. FreeCAD can do everything. It has the technology to do everything that you need it to do. Does it have an equivalent operation? We're now talking about like user experience, single button click kind of things. Not as much. So it's possible, but it's not as easy. If you look, those of you that are familiar with FreeCAD are potentially confused by this data point of properties there, because FreeCAD does have a thing called properties, but I just want to point out SolidWorks properties and FreeCAD properties are not the same at all. The need is not met. But even that's not the question. The question is it easy? And this is subjective, but it's less easy. Going off on a brief tangent here, another potential issue is assemblies. Assemblies are when you take multiple separately designed parts and you need them to interact with each other. It allows you to check sizing, spacing, things like that. It's really essential when you have complex multi-part designs. And it's currently not native to FreeCAD. Collecting a bit more data, I spoke to all my mechanical engineer friends. They were all totally willing to drop Windows and drop SolidWorks and give free and open source software a try. The one thing that was holding them back was SolidWorks. So I said, here's FreeCAD, let's talk about it. We were walking through the entire process, and as soon as they found out there weren't assemblies, they weren't interested. They were done. You can get assemblies in FreeCAD. You have to import them on a workbench, but it's not native. So let's learn from this data. FreeCAD is a really awesome tool. It can do everything you need it to do. The issue is that the UI is what's holding it back right now. It has the technology, and it's a really important project, which is the only reason why I'm kind of nitpicking these guys. I think it's absolutely a critical project for this movement. It just needs a push in a stronger direction. Assemblies are a potentially overlooked need. Workbenches could be streamlined. Workbenches are how they split up different functionality into different areas. They don't always play nice together, and I think it's really telling the fact that experienced users will unsplit this split. So that's worth paying attention to, I think. And it's all worth paying attention to because there's a very real demand for gratis and for entry-level CAD. If we look at tools like Tinkercad or Onshape, which are free to use, cloud-based tools, they've done really well in the market. In fact, Onshape was founded by executives from SolidWorks. So, the people who are experts in this industry agree that there is usage here. People are willing to use this stuff. Even if we solve the issue of having free and open source professional level CAD tools, that doesn't solve a separate issue, which is we need entry-level CAD tools. We need that for greater accessibility for all users, which would expand freedom to a wider audience. It would also allow us to reach into the maker movement. So connecting to the maker movement, it's a potential entry point to spread free software ethics because, again, there's that very similar overlap of interests in the ability to tinker, share, modify, and so on. The maker movement is, it's got a much larger reach than the free software movement does. So if we can take advantage of that, that would be great. Previously, we haven't really had a strong entry point to the maker movement. 3D printing might be a way to bridge that gap. If we can really cement ourselves in 3D printing is already really cemented in the maker movement. So we just have to get over this bridge of 3D printing people viewing freedom as good as opposed to necessary. If we can get them to agree that it's necessary, then we've got ourselves in the maker movement, just because of how intrinsically they're tied together. Another issue that the Free Software Foundation or movement is bumping into that potentially 3D printing can work on is a lack of freedom in education. Getting the next generation of engineers and of thinkers is really critical for any philosophical movement, but ours in particular. We need the engineers that are building things to be building free software. And I want to ask the question, is this an aging movement? I don't have any real answers based off of data for that, but I've been coming to this conference for a few years, and I've noticed there's very much an average age, and it is older than I am. And I think a big part of the factors for that are, as I said before, I think my generation largely takes freedom for granted. And I think the older generation has seen the transformative power of technology and is aware of that power and takes that power more seriously. Other issues, so again, I don't really know if this is an aging movement or not, but either way, the fact remains that we need the next generation of engineers and thinkers, and that's students. Students aren't really getting taught free software in their courses. It's not a priority in the majority of tech courses. If you look at IEEE, ACM, which are the leading technical professional societies, they put together their recommendations for curriculum. And for computer engineers, they recommended no more than 3 hours throughout the entire curriculum. And it's really not much better for computer science. So partly as a result of all of that stuff, partly just lack of exposure, students aren't really aware of the need for free software, and that's something I can attest to as a student, even in the computer science field. So if it's not going to happen in class, it needs to happen extracurricularly. It needs to happen outside of class. EasyCAD and 3D printing are a potential fix in this area. If we can get easy CAD tools in the hands of students, then we're looking at a method for spreading this technology that is already intrinsically connected to free software. 3D printing is already really popular on college campuses, both in the sort of spaces that I described to you previously, but also, I mean, when I was living on campus, I would roam through the dorms and just see 3D printers everywhere. People were just playing with this technology because it's kind of a fun, nerdy thing. So it's really popular, and that's something we can insert ourselves into. And thankfully, students, by nature of the fact that we are students and we're young, we're more receptive to these new philosophies. So now, as students, is a really good time to be exposed to these concepts. So wrapping up here, 3D printing really benefits from free software. And free software, I think, has benefited from the existence of 3D printing. But free software modeling tools need to be made a higher priority. The Free Software Foundation has their list of high priority tools or high priority projects, and there's nothing about CAD on there that I've been able to find, which I think is kind of worth paying attention to because, I mean, again, CAD is literally the entire man-made universe. So it seems pretty important to me that those tools be free and be open and be accessible. We haven't really taken advantage of 3D printing as a free software opportunity actively. We've benefited from it passively, but we can take active advantage and get even more out of it. So I'm hoping that the major takeaway from this for everyone is that you view 3D printing as an actionable method to increase freedom in your local communities. So with that, thank you.
Thank you, Chris. We have time for questions. If you have any, please come. If you can't come down.
If you shout, I can repeat it. Or that, yeah.
Might be a little long. I'm an inmate at Artisans Asylum over in Somerville. I don't know if you're familiar with it or not, but we're one of the premier makers.
I've been meaning to check you guys out, actually.
You should come and take a tour. We got 40,000 square feet of awesome. Unfortunately, our computer lab is SolidWorks, HSM Works, the Autodesk Creative Suite, MATLAB, and Simulink. We do use KiCad in the circuit lab. I'm handicapped in a lot of ways by the fact that I try to avoid using the proprietary software in the computer lab.
Right.
I've been trying to teach myself FreeCAD and found it a very frustrating process.
Yeah.
And so I'm like, how do I get from LibreCAD that I've been using for years, and which does a great job of 2D, but I can't translate
3D,
that drawing from my 2D CAD program into 3D.
Right.
And I also have my own feeling about limitations of 3D printing is that right now it's very limited on what you can do for real-world usable objects. You know, I look at it of saying, can I make parts for my chair? Not really. Cosmetic stuff, yes. Functional, structural things, no. I want to go to the milling machine, and for that I need to do subtractive software to be able to generate G-code toolpaths, which again
Proprietary.
seems to be missing from the free software world. And so I've been complaining about this for as long as I've been coming to these conferences saying we need to get into CAD.
Thank you. Yeah, I'm glad to see that there is other members of the community viewing this as a priority. Yeah, I agree with what you've said. Thank you. Hi.
So I just walked in halfway through the presentation. So
Sure.
forgive me. Did you cover OpenSCAD at all in your talk?
I touched on it briefly.
Okay.
I don't view OpenSCAD as a viable option for the end user.
Right. It certainly doesn't have a lot of the professional level parametric stuff that, but it is fairly widely used, which is why I was bringing it up. And are you aware of any more standalone methods to do that sort of assembly work? Like if I have a couple STL files or
Sure.
OpenSCAD files or whatever, of just kind of interposing them.
Yeah. Well,
Outside of that.
there is a pretty widely used FreeCAD workbench that you can download externally, called, I think, Assemblies 2. I don't recall exactly, but you'll be able to find it on the forums.
Okay.
If you wanted to get your OpenSCAD stuff into FreeCAD, you can export it as an STL or a .step and go from there.
Sure. And so the workbench is kind of like a different UI setup?
Yeah, they have workbenches aimed at architectural stuff, aimed at part design, things like that.
All right, thanks.
Yeah, thank you.
I think we really miss a lot between electricity and plastic. We have to merge those two items to show people benefit of the three designs. Three designs including electricity circuits.
Mm.
In this case, people, because like the person mentioned, we cannot deliver easily mechanical parts strong enough, but in terms of electrical, we need an electroconductive filament to add.
Well, I mean, when you're talking about conductive filament, that gets into, I have not seen any consumer printers doing any 3D printed PCB stuff. It exists, but
Prusa can print two filaments simultaneously.
you can modify it to make it do that, yeah.
Yeah, so all we need is one conductive and one non-conductive, that's it.
On surface value, it seems that way. The issue is that by nature of the temperatures that these things are capable of getting up to, you're printing out of some form of plastic. So for example, I actually have a part here, which this is called wood fill, and it's got a large amount of wood in it, but it's still primarily PLA. So we can do similar things, but then we're going to notice a drop in conductivity, which starts to get messy when we're talking about the electrical flow and so on. So we could see, if you were interested in doing your own PCB manufacturing, subtractive manufacturing would be where to go. Yeah, so subtractive as in, like you want to have a shape like this that is also that'd be cool. That would be cool, yeah. Yeah, 3D printing is interesting because it's almost never the best solution to a mechanical problem, but the reason it's so widespread in mechanical engineering is because it's a good enough solution to pretty much every problem. So if we can get really good free and open 3D printing, we have the entire manufacturing market, as long as it fits within a space about this big. Right, and you print things in multiple parts, and you're fine.
I guess this is an extension of his. Have you seen anyone try to do electrical conductivity with graphite filament?
No, I haven't seen that.
That would be an interesting thing.
Yeah, I don't know how effectively it would conduct anything. I just don't know. It'd be kind of cool though.
I just thought I'd bring up, I'm not sure if you mentioned it earlier, but something that's has such huge parallels to the free software, really software in general, is the RepRap project.
Yes, that
Because
was
you did
the
talk
guys I
about
mentioned
that,
first,
because
yeah.
of the idea of copying a physical object is like, oh, software, you could copy it for,
Yeah, exactly.
virtually no cost. So, all right.
We're out of time now, but thanks again to Chris, and
Thank you.
see everybody tomorrow.